Next up is Ramtin. You may have know him as a rap lead from last year, but he's actually got quite a knack for power electronics as well. So he's going to be showing off his flyback converter.
Well, hello everyone. As Dominic said, yes, last year I was very much into RF hardware, and this year I decided to explore some other areas, which happen to be power electronics. So why did I choose flyback converter in the first place? 2 summers ago I was interning at a company, and well, I was making a sensor, but then one of my projects was to they call it power derating, but basically I had to figure out how much heat each component dissipated on a flyback converter. Now, what is a flyback converter? It's a converter that changes voltage to a DC voltage to another DC voltage. Could be lower, could be higher. For this converter that I've made, the input voltage can be 9 to 18 volts, and then it will always give you a steady 5-volt output. And it does it with pretty high efficiency, which is the worst case it's 70%, and it can go up to 80 and possibly close to 90 as well. Why is this a power electronics project? Because, well, the output power is pretty high relative to what you have seen. It's 2.5 watts versus in your other classes, when you deal with microcontrollers, these are all very low power devices. So when the power goes up, certain aspects come into play, like the losses in your MOSFETs become important, things start ringing, your inductors and capacitors. So there's actually quite a bit of math that goes behind how to design a circuit that's efficient enough to not dissipate so much heat when you convert 18 volts down to 5 volts, because it's a pretty big jump. You may be wondering, well, Ramtin, how come we can't use just a linear voltage regulator? The reason for that is that a voltage regulator will simply dissipate that power as a form of heat. So when you have a very large gap between your input voltage and the output voltage, you will generate a lot of heat, and you can even burn the circuit. So that's why we use a completely different category of circuits, which are called switching converters. Flyback is one of the basic ones, which is found in many of the chargers and adapters as well. So what was the design process for this project? So obviously the first part was just reading through a bunch of literature, textbooks, Texas Instruments, notes, analyzing exactly what voltages each node was seeing, and then tuning your values for capacitors and inductors and transformers. Well, obviously the next part would be to simulate that circuit, and for that one I did it in LT-Spice. You can see that the simulation actually came out pretty well. If you compare these two plots, you can see that, for example, the red plot here, you see a little bit of ringing and then a dip and then it goes back down. Here LT-Spice shows the very same behavior. Also for the red plots on the top, we have these white triangles. For the green one, we have the green triangles at the bottom. So once this simulation was good to go, I ordered a PCB, which I received it, I believe, in the middle of winter. And I connected it to the power supply, and the scope showed something completely different. The problem was that I had chosen the wrong transformer. So the transformer plays a very big part in this converter. What this converter is doing is that it's dumping some energy into the inductor. Inductor stores it in its magnetic field, and then you turn off the switch, and that magnetic field collapses into, again, electric current on the other side. So here, when this MOSFET is on, you have current flowing, storing energy in your transformer, and then when the MOSFET is off, the energy dissipates on this side. Now, what was happening in this case, because the transformer was wrong, was that it's a phenomenon called transformer saturation. Basically, the current in the transformer is rising, and then at a certain point, transformer can no longer store the energy. So it's just gonna draw a bunch of current. And that's what we are seeing on this plot. So the current is building up, and then all of a sudden it shoots up. So what happened was that a lot of the components were getting hot. I think some of the capacitors started smoking too. So yeah, not good overall. So for part 2, what I did was, not only did I find the right transformer, but also I had to design a loop, a control loop around it. Why do we need a control loop in the first place? So let's say I connect the load, and then due to some non-idealities, it draws more currents, or my power supply is not exactly at 18 volts, it's fluctuating. So I need to constantly monitor whether or not the output voltage is 5 volts. And we do that through control feedback theory, which many of you may be familiar with from your 141 course. This feedback is a little bit more complicated than that, in the sense that it is 2 feedbacks nested into each other. So there's one feedback that's monitoring the voltage, but then there's also a feedback that's monitoring the current that's flowing into the transformer. And the reason for that is that, let's say someone accidentally shorts the output, we don't want the power supply to just give a bunch of current to it. Like, we want to make sure that it rises until it reaches 1 amp, and then after that, no more current. So that also, it acts as a mechanism to protect the circuit, but it also makes the overall loop more stable. So what you're seeing here is the final products. I tested it 2 days ago. It works. David helped me a lot with debugging it as well. So thank you, David. But yes, if we actually plug this into a power supply, you will start hearing a sound. Well, probably not as cool as Connor's, but that sound is the 150 kilohertz switching frequency of the converter that I said it's giving current and then cutting it. So this is pretty much it for the project. The main reason I decided to do this was, first, I wanted to explore power electronics, and secondly, the reason I decided to do this project with IEEE was that so that IEEE will have these designs and the step-by-step process for it, so that later on, maybe next year, if there's any student who wants to get their foot in power electronics, they can have a project to serve as a reference. And yes, that's pretty much it. Thank you very much.